Hello, this starts 7.3, Concepts Related to Chance. A numerical value that represents the degree to which we believe that an event will or will not happen is called the probability. So in other words, I look at the number of favorable outcomes over the total number of outcomes. So if I talk about flipping a coin, I have two possible outcomes, heads and tails. A favorable outcome is getting a heads. So the probability of flipping a coin is 1, because there's 1 heads, out of 2 total possible outcomes. All right? Each outcome to an experiment is an element in the sample space. So heads is an element and tails is an element. So if I want to write the sample space for flipping a coin, it's a set, so it's the set of all possible outcomes. So I use curly brackets, H, comma, T, in set notation. And so I guess it would help if it would have this be on there for what I'm reading. So curly bracket, H, comma, T, H for heads, T for tails. Right? The subset of the sample space is called an event. So tossing a coin is called an event. So getting a heads is called an event. So we said that the probability of a heads is 1 out of 2 because there's 1 heads out of 2 possible outcomes. The probability of not a heads, so the probability of not a heads, so I can use a tick mark to mean not. I could use a bar to mean not. Both of those mean the not. In this case, since there's only 2 possible outcomes, it could be tails. And so the probability of getting a tails is 1 out of 2. If I add these probabilities up, so 1/2 plus 1/2, then that equals 1. So all the possible outcomes, if I sum them all up, that will always equal 1. An impossible event is an event that will not happen. Okay? That is likely not to happen. The probability of an impossible event is 0. So the probability of rolling a 6 when I flip a coin is 0, because when I flip a coin, there's no way that I'm rolling a dice. The probability of a certain event is 1. So the probability of getting a heads on a double-headed coin is 1, because there's only 1 possible outcome. And no, I don't have a double-headed coin. A simulation is doing an experiment over and over again. An experiment is finding 1 probability, or doing 1 toss of a coin, or 1 roll of a dice. Okay? The law of large numbers states that the more you perform an experiment, so if you do it over and over again, then the closer the probability will become to the correct number. So in other words, we've done this for our kids, that George did this for his first grade science fair project. He took a quarter and he tossed it 50 times to find out. His hypothesis was that the probability of getting a heads is 1/2. And so he flipped a coin 50 times and wrote down whether it was heads or tails. What he actually found was that the probability of getting a heads was closer to 60%, not 50%. And so the law of large numbers says that the more you do the experiment, the closer you should come to that probability. So the more that he threw the coin, the closer he should get to actually getting 1/2. Which, let me just say this as a side note, is that is really not true when you flip a coin. The heads are a little bit weightier. They have a little bit more weight than the tail side of a coin. And so, at least in the old quarters with the bird on the back, with the eagle on the back. The head side is just a little bit heavier, so you actually end up getting the tail side a little bit more often, not the heads. Two events, A and B, are mutually exclusive, and that is that the probability of A or the probability of B is A plus B. Now, this means that the events that means that A and B have nothing in common. In other words, if A is tossing a coin and B is rolling a dice, those are mutually exclusive events, because if I roll a dice and I toss a coin, there is nothing that they have in common. There is no way that those two things overlap. If we have two such events, then they are called complementary. That means A plus B equals 1. The probability of event A is X and the probability of event B is Y. Then the probability of event A then B is X times Y. So that's the probability of A times the probability, that means that B happens second, that it's going to be X times Y. Two events are dependent if the probability of the second event is affected by the outcome of the probability of the first event. So in other words, if I have if I want to, and I did not grab a deck of cards, I'm trying to think of a way to illustrate this. Think about a deck of cards. So you have 52 cards in a deck, okay? The probability of pulling a heart out, there are 13 in each suit, there are 4 suits. To pulling a heart out is 13 over 52. If I put that card back in, so I pull a card out, I want to pull 2 cards out of the deck. If I pull 1 card out and then I put that card back in, then putting that card back in, the second pulling of the second card depends on does not depend on what I did. If I keep that first card out, so I pull 2 cards, so you're dealing cards to play cards, and you deal 2 cards. So the probability of dealing the second card depends on what you dealt the first time, because you keep that card and you don't put it back in. If I put the card in, they're independent. I hope that makes sense. Have a deck of cards. I pull 2 cards out. If I pull the first card out and I keep it, then that makes the second pulling of the second card dependent on that first card. If I put that first card back in, then that is, to pull the second card is independent. Sorry, I was having to cough. Expected value is the mean of a random variable. So this means if I want to find, I'm betting, and I want to find how much I should make, then I'm going to average up all my chances and all my probabilities, and I'm going to sum those 2 up and how much money I should win, and I'm going to find the mean, the average of that. Then that's going to tell me how much I'm expected to win. So expected value, another way to look at this, is that it's the value that you're expected to win when you're gambling. It's your expected outcome. And it's calculated by finding the sum, by finding the probability of the event, multiply it by the sum of the outcome, so the cost of the outcome. Right? That ends the notes for 7.3. We're adding 7.4 onto this. Their 2 sections are kind of taught together simultaneously. Okay. Trees. Trees are used to calculate probability for multiple events happening. Okay? So if I can do the card pulling if I have um, I could do candy out of a bag, marbles out of a bag, gumballs out of machines, anything that has more than one events that are going to happen. So if I do event 1, then I do event 2. Okay? The way you construct a tree, you're going to have branches and you're going to have your starting point. So you're going to start here at your trunk. Okay, so this is the trunk. Okay, and this, so I have the probability, so I have event A and event B. And so this is event 1 happening. Right? And this part right here are called my branches. I am looking for my pencil off my desk. Sorry. And it's in front of my head. So this is the trunk, and these are my branches. Okay? All right. Then I'm going to take event 2. I could get C or D, C or D, and this is event 2. Okay, and so, and these are more branches. Okay, so I have branches here and then more branches off of those. Okay, now I'm going to erase my branches because I want to write information here. Okay, so this right here I'm going to put as the probability of A. I don't put it at the end of the branch, I put it on the branch. So the probability of that branch is A. This probability is B. Okay, so my event is at the end of the branch, my probability goes on the branch. This is the probability of C given that A has occurred. So I write that as, so the probability of C given that A has occurred. Okay, that is written as the probability of C bar A. So this is the probability of D given A, the probability of B given C, the probability of C given B, and this is the probability of D given B. And so that's how I write my tree. Okay, now notes. If I want to find, first note I should say is that the probability of A plus the probability of B equals 1. So the probability on a set of branches, so here's a set of branches, here's a set of branches, and here's a set of branches. So I have 3 sets of branches. So the probability on a set of branches is 1. So that also means that the probability of C plus the probability of B equals 1, whether it's given A or given D. So the probability on this set right here is 1. That should be a D. So I'm talking right here, I'm talking about just on these 2 branches. If I ignore this, those 2 probabilities should add up to be 1. Now, to calculate the probability of C. So I want to calculate the probability that C happens. So that's that end number. So the probability of C equals the probability of A times the probability of C given A plus the probability of B times the probability of C given B. So remember what we said earlier. We said that if we had the probability of event A happening, then the probability of event B happening, then we multiply. So that means that I multiply from here to here. So when I go across the branch, I'm going to multiply right there. And I'm going to multiply right here. But I'm going to add between these two stems, between these two big stems. Okay? I'm going to add between the two big branches. All right. The number permutations. Permutations are the number of different subsets of R that we can make from a set size n. Okay, so in other words, if I have a set of n things and I want to take them R at a time, okay, think about it as this way. So say we have a group and we want to pick them in a certain way. So we have certain titles. So if I have a group and I want to put these from smallest to largest, then this is the smallest, this is the next, if I'm talking about vertical height. Then I have the cube. Okay, so if I want to put these, if I have this set of 5 objects and I want to put them from smallest to largest being in height, smallest, largest, next, next, next. Does that make sense? So I have a specific order that I want to put them in, then that's a permutation. Okay, but if I have the same set and I just want to grab 3 of these, then that's a combination. So I don't care what the subset is, I just want to grab and make a committee of them. Then that's a combination. All right. Now we get to examples. Okay, so we're going to start, and these examples are numbered correctly. Starting in Chapter 8, your examples will be numbered differently. Okay, and so before we start actually working the examples, I'm going to stop the video and cut it into a different size so that you can see the 2 different sizes.